Hi everyone, this is the GraphQL for GovTech talk. I'm very excited and very grateful to be here talking about my work with technology and government, both things I'm very passionate about, and somehow, fortunately, they've intersected for me. Uh, I really couldn't have done a better job at describing my talk than the conference page. So that's my introductory slide. Uh, it's not a very typical tech talk. So there's going to be a lot of context that I'm going to have to set. So before we jump into that, let me just quickly talk about myself for a very, very short while. I'm Bharat. I work at Samagra, which is a governance consulting firm in India. And we work with states or provincial governments and in an attempt to improve the quality of life of citizens through better governance. That is the mission. All right, so let's dive in. Okay, let me just, yeah. All right, so this is not a very typical, as I just mentioned, it's not a very typical engineering conference talk in that it's talking about a sector that's not very well defined, that's not very frequently talked about. What is GovTech? Is it even a thing? Or is it a term that I've just invented? So I thought it was important to spend some time defining the contours of what GovTech is, how it has come to be what it is, and what we at Samagra are doing inside GovTech, right? So we'll trace the evolution of GovTech through through three phases of its development, and these three phases roughly map to the last 40 years of Indian history, right? So the first phase, or roughly the late 80s, early 90s of technology inside government in India was the computerization phase, right? So computers began coming into India, began coming inside government offices. So if you had forms that you would typically buy from the local government office, these became Word documents that you could get off of floppy or a CD and so on and so forth, right? So that was the level of computerization that we saw in this time. Now, following that came the era of digitization. And what that meant was, so if we take the form analogy from the previous slide, it became that instead of getting it from a floppy disk, you could now download that form off the internet, fill a part of it, and then upload it back, right? So in most cases, the entire service would not be completely digitized, but at least a part of it you could fill online, and then eventually you would have to go back and queue up and complete the process, right? But digitization began to creep in passport offices, PAN applications, and so on and so forth. So tech in government became limited or became digitized, right? And now the final piece of the jigsaw, which is very important, is public digital infrastructure. And this is so new that it's not a term that is very easily understood. So I'll try and explain what I mean from public digital infrastructure. By public, the idea is that this is government owned and it's transparent. So if there are specifications, there are going to be comments, and there are going to be consultations from the public at large, right? And from digital infrastructure, what we mean is that these are not products. These are services and facilities, just like physical infrastructure, which is available for people to do their own thing with. Similarly, this is digital infrastructure that allows people to use it and then build on top of it, right, in a modular fashion. So continuing the form analogy, what this meant is that instead, now you have digital infrastructure that allows you to download forms, use your phone. The applications can fetch data from different databases, so they're interoperable. You can sign them through digital identity. You can pay through financial pipelines that infrastructure has built. And finally, you can complete the application all virtually, right? This is enabled, this is powered by different examples of digital infrastructure that we've seen come up over the last few years, right? So what is the GovTech ecosystem? It's a motley crew of organizations that are trying to build open source components inside government, and Samagra is just one of these. Since it's not a very a space that will see consumers and customers very often. So it's more collaborative than competitive. But we at Samagra are one of these multiple organizations trying to build open source tech for governments. Right, so we've had enough context. I think it's time to dive deep into what we're here for. I'll talk about two case studies in particular. These are two states that I've highlighted in the presentation. I'll begin with the first one, which is the northernmost of the two, which is Himachal Pradesh, which is a hilly state in the foothills of the Himalayas. Now, what we built here over the last 4 years that we've been working in Himachal is digital public goods for school education. And when we came here, there were a number of challenges related to technology in school education in the state. There was no unified student database. It's a remote, parts of the state are very, very remote. So student-teacher communication is a challenge. And finally, there were no systems at all to monitor progress, to monitor whether students are gaining learning levels, on if the learning outcomes that should be met are being met at all, right? Now I'll go through the solutions that we've developed for each of these challenges over the past 4 years. And we began with infrastructure for data collection, right? So eSamvad is nothing but a mobile app that's built through open source tech for teachers to be able to collect data and feed a student database. So what we've done through eSamvad over time is build a Postgres database that is the largest and unified student database in the state. And leveraging this data, we've eventually gone on and built systems that enable authorities and administrators in the state to monitor learning level progress, right? And a number of other things related to students in school education. Right, we'll move on to the next stack, and I've purposely created the slide very similar to the one earlier, because the idea is that it's almost exactly identical. And that is the hypothesis that we've verified over the last couple of years, is that if you build systems and components that are configurable and extensible enough, if the use cases are going to be very, very similar across states. So in some sense, the analogy is with large enterprises. If you crack one, you will eventually be able to crack all of them, right? So using almost exactly the same stack, we deployed public goods for school education in the other state, Haryana, right? So the use cases are in some cases identical, in some cases they are dynamic and very new, but the components that we wired together and deployed differently in different states are able to handle both at the requisite scale. An example of this is COVID patients and employees level, district level reporting of cases in the state. So a very dynamic use case being managed through the same stack. I'll end with learnings that we've had deploying GraphQL in perhaps the greatest enterprise of them all, government. And I'll start with the challenges. And one challenge that you might expect is migration. So government, like any large enterprise, has its own systems that they've been running on, particularly Microsoft SQL Server, very, very popular in most governments. And the fact that it's not very easy to migrate, not just the tech of it, but also the know-how and people to maintain newer systems is a challenge. What I see on the horizon is larger organizations building things, for example, Amazon, which is just open sourced Babelfish for Microsoft SQL to Postgres migration. So that is a big space that is going to see a lot of work for the GraphQL ecosystem to prosper. And the second part is community. So GraphQL exists because of its active community, but sometimes the features that we would want to prioritize for governments are not the ones that are being prioritized by the community. And that is, of course, a common challenge for open source systems. I'll end with the benefits. And of course, these outnumber the challenges by far. The first is it's fast, and I don't mean fast in the performance sense, which it is, of course, but it's easy and fast to set up. We've had this belief coming from government offices and tech system administrators when we say that we can set up a database, a dashboard to visualize large amounts of data in a week. Because typically this is contracted out to vendors and they take months and they build proprietary software that costs a lot, right? So we're building free 5 days and it's difficult to accept. It's configurable in the fact that you can work with any system, any stack. You're not dependent on a particular stack or a particular library to work. And finally, it's scalable in the fact that not just from state to state because it's extensible, but also when we move from a state to a state, we see 10x the scale, and yet we're able to manage. We've been able to manage. That's what we've seen. And going forward, we're going to be deploying the same stack, the same components in a state that's 10x larger than both of these. And we're very confident of being able to meet those challenges and those use cases through GraphQL and through the stack that we've developed. And with that, I come to the end. This is Samagra's tech in the background. So people in the GraphQL community who want to contribute to GovTech, do give us a visit. Thank you so much, Hasura, and thank you so much, GraphQL Asia, for having me.